Good afternoon, everyone. I'm here for some plane shift development, and everything is going okay on my side. I've been a bit busy during the week, but pretty much okay. I had the time a bit in the evenings to actually do some reasoning on how to organize our mini games. Now, there is some people saying that I should not waste time with mini games, but I think it's a fun piece of the porting. We had some mini games in the old plan shift, and they were mostly related to kind of a chessboard, so able to move pieces and put pieces in certain cells and such. So, but there were no rules on it. So basically, you had to agree with your opponent or with your other player um, the rules to use while playing the minigame. While here I'm looking at something different, which is more on trying to create mini games which will be used for crafting or will be used for like puzzles for unlocking something or puzzles in certain dungeons or I don't know. I'm just exploring a bit what we can do with mini games and how hard it is to do a mini game because I want to know if I can use them for real or not. I guess yes. The answer is yes, but I just want to be sure. I just want to test it a bit. Hello, hi. Hi, Jet. Yeah, exactly. Yeah, yeah. That's one point as well. It's something a bit innovative, just to explore the engine and understand how it works. So, in terms of mini game, we had some reasoning the other day together, right? And we had some categorization of our crafting and or the areas where you are working with your hands on a mechanism or something like lock picking or where you are fishing and such. So, and we were categorizing those in the following way. So the first category is liquids. Hello, Sway. The first category is liquids, where basically you have to mix or you have to cook or you have to, take care of a liquid or of something in a pot. And so the idea was to create a kind of a mini game where you can click on the bubbles as they appear and the complexity. Remember that each of these mini game need to have a way to scale in complexity, right? Which is the most important feature of those mini games. So the way they are designed, they should allow us for a broad range of skill. So let's say that for the bubbles, the easiest possible is that you have one big bubble in the middle, you click it and it's done. Okay, so while the highest is that you have a number of bubbles of different colors, you have to click only on certain colors and not on the others. And these bubbles are moving, and you have a limited time, and you have to catch a certain amount of certain number of bubbles in that time, right? And so it starts to be pretty complex, right? And so this one gives us the ability to scale up or scale down because we want to scale based on skill and based on the complexity of the item. So that's the idea. Then the second category is weapons. What the forging of weapons is mostly like a blacksmith being at the forge, and so using some metal and putting in the forge and heat it up and then hammering, so like giving shape to the metal with a hammer or with other tools. So the idea here was that you had to use a hammer, right, which is your primary item on the left mouse click, and you have somehow to keep the left mouse pressed on hold. I mean, holding it down in this kind of scale, where you can decide to hit a particular point when your hammer is at a specific scale, right? Now, it doesn't exactly match, like the hammer is not heating up, obviously, but it's just to say that you have to give the proper hit, so you need to give more strength when it's red, less strength when it's yellow, and even less strength when it's orange. And I would say the cold one you should never hit. So also here I think we can have a kind of it's similar to the bubble. It's the same principle. The difference is that you have to hold down and choose your level of hitting. And also here there can be multiple areas that are heating up and multiple areas that are cold, and you have to hit them at the right time and such. Now, I don't know if you also want to have the heating, so like you have like the left mouse and the right mouse. Let me think about it. I think I had a mouse icon already last time. No, I'm a real mouse, not the mouse. This mouse, yeah, exactly. This one is perfect. So like the idea could be, but it's still to be understood, right? Still to be sorted out. But the idea could be that you have, on your mouse, right, the left side, which is the hammer, right? The left button, which is the hammer, and then you could have the right button. Where we have a yellow background, which is the heating, right? I just don't know exactly if the heating should just be keep it pressed. Yeah, maybe you should just keep it pressed. Like you press the right mouse button and you are in a specific place, and this creates a heating, so it heats up, so it becomes yellow and then red, and then you can hit it with the mouse or not. I don't know. I'm unsure if we need something here. I don't know. I have no idea. Maybe we will. Maybe we will not. I don't know. I have to think about it. Then there is a third one, which is the one that I'm doing now, which is the armor. For the armor, what I was thinking and what I'm building, I'm a bit slow at building this because there is a bit of Blender knowledge involved, and I'm not really a Blender guy, but so the idea is to make a kind of a board like this one that you will see from the top, similarly to the one that we did previously, with the bumpers. But I simplified it. I did it. I used another technique. I will show you what this one does, right? And you will have these kind of blocks which are placed one next to each other and with a specific texture, and the texture will tell you let's say the path or the route you have to follow. And then there will be kind of bumpers, right, similar to the one you've seen on the right, but in this case they will be probably invisible bumpers that are giving you the direction where you should go. So like, well, not the direction, like the road where your car should drive, right? So like this thing. So you will start from here, and you will have to go through this without touching the borders. Now, the player will not know that there are borders because those will be probably invisible, but he will see here on the ground a path or a sign, like a direction. And so he will see that if he goes too much to the left or to the right, he will lose points, or he will have, or will get in trouble. So So now the point is designing our puzzle, right, the proper way. And let me see if I have here imported all the pieces. So I created also another piece. It's not here though. Okay. Yeah, this was my test in Blender. Let me save this and let me try to export it again to FBX and see what happens. And if I import it again, I don't know if it's importing the same object, so or if he's smart and he only adds the third one. Okay, since he's smart enough, he's only adding the third one, so this should be. Yeah, I didn't complete the back facing. Okay, so I have to do that. But just to give you an idea, this one could be rotated, 90 degrees, and could become, the next part of the story of this path. Now this one I think is old, so it's not really matching. Let me see if it's matching now, because the new one should match perfectly. I use this trick. I copy the location. I will tell you what I'm doing then to ensure that all these pieces are in the right place. Because I had an idea and the idea seems to work okay. Why this one is not proper? Because I rotated it 90 degrees. Yeah. So if we rotate it 90 degrees, yeah. But anyway, you see the pattern, right? So like here, this will be the path you need to follow, right, with your thingy. And so if you want, I can show you. I can play it, because anyway, it's like at the moment I'm doing no automatic generation. Okay, it's just manual. But you see that here you have this small thingy going up. And so you will know that you have to go through this path because there will be something printed on the ground. Now there is not. And your pointer or your tool will will create markers, which for now are just two white lines, but in the future could be the sewing, or the riveting, or whatever else you need to do in that particular mini game, right? So the point is to create, now unfortunately the colors are a bit shit, so it's not very easy. Can I have a kind of a different color, please? Yeah, that's much better. So I don't know if I can put this into steel. I think it would be much better. I will fix the textures later on. For now, so yeah, so like this, it will be a bit more visible, right? Wow, gold is so reflective that that the light is making it impossible to see. Okay, but now you get the point, right? So it's like you go through this, and then you go through this, and if you are touching coming out of the predefined path, you will lose points, or the quality of the crafted item will be lower. So now the point will be to, gold is impossible. Is there another gold, or is the only gold? No, it's the only gold. So I think we can have, what we can have? We can have exactly the opposite. We can have this part of steel, and by the way, there is also this other steel, which maybe is less reflective. No, it's reflective in the same way. I think I can change the reflections anyway, easy. I'm just too lazy to do it. But okay, also this one. I think because I have a light, which is just sun, which is just at the top. But yeah, maybe we can do the opposite. We can have this one as gold. What do you think? Being perfectly vertical is not really showing any color, because the sun is just on top of me and there is no diffuse or something. So but so the point is you will have a certain number of blocks, right? And this block doesn't have a material by default, right? No. So I need to set it every time. Yeah, I need to set it every time, I guess. Okay, I can do that. And so you'll have a number of blocks. Now the point is how many blocks we want in the mini game to make it scalable enough. So I came up with this side, and this side seems to me reasonable. Right? Like you can actually go through with your mouse, and is good enough. Let me try to see it now. This one, if I take the location, I just copy the location and paste it on top of this guy. Yeah, in this case it fits. Okay, I just need to make it double-sided, but it seems to work out okay. And then here I copy the location of this guy, I put it on this guy. Now we will need yeah, and you see, and now they fit. Okay, apart from the fact that that guy is not, it doesn't have all the double-sided, and so you see through here because I didn't make the double-sided. But basically, the puzzle maker should be able to, you know, build this thing. Should be able to build a path. So how many we want? I think if we have 4, 8, 12, 16 is already a lot. I think is already a lot. I mean, it's already complex enough. Also because these shapes, now I have only 2 shapes, but I can have like 6, 7 different shapes, and some can be a bit nasty, like hourglass, like an hourglass shape. So maybe they can become harder in the middle here, so that it's harder to go through, and so we can invent whatever we want, right? Now I don't know if I also want to have a time. For sure there will be a time, so there will be a maximum time to do it. But then I don't know if I also want to have a number of signs on the ground, a maximum number of signs on the ground, or a minimum number of signs on the ground, something like that. Like if you are going, back and forth. For example, if you're going back and forth, you will put 2 signs in the same place, and this could also lower the quality, I guess, of the final item. So our job. So for this, I don't know if I have a kind of a mini game mission. I think I do, but I think we should. Is there a way to see this not in a? I mean, it doesn't really look great, but yeah, it doesn't really look great because this thing should all be golden and should all be double thingy. Why this one is really fucked up? Okay, I will have to fix it. But anyway, this is the idea of the mini game, right? I think I can take a simple screenshot and put it here, and just take it just for a reminder of what we want to do. This white ball, okay, it's not the best. But yeah, the point is that here this obviously will continue here, right? Now it doesn't continue at the moment because it's a bit bugged, but I will fix it very soon. So yeah, so this is how it should be, right? Okay, so this will be your path, right? So what you need to do, you need to go through this, you need to go through this, you need to go. I don't know. These arrows are so. Yeah, maybe it's better. I make it a bit smaller. You will have to go through this, and then there will be an ending, right? There must be an ending somewhere. There must be an ending somewhere, like here. So I didn't make it yet, but there will be an ending. We go through that, which is similar to what I did in the other mini game. If you go here, you will see that this green thingy is the ending, right? So it's the finishing line, let's say, right, of the mini game. So yeah, so we have this one, right? So for armor and metal, yeah, it's too big actually. It's really big. It is really big. Let me see if I can resize it to like 50% and still looks okay. It still looks okay, so maybe we can even resize it at 30% and it will still look okay. Yeah, I think it's fine. I think it gives you an idea of what we need to do. Okay, so this will be our mini game for armor, metal, and leather. Now there could be different ideas, like you may do multiple passes, like with different tools. So like you will have to do a riveting, I mean a punching first. So you are punching the leather and you are creating holes, and then at the second round you are like sewing. Okay. Or for the metal part, there will be again the punching and then the riveting with metal rivets, right? There may be glue, there may be, I don't know, whatever. I mean, we can invent whatever we want in terms of passes. Yeah, so this one I think also is very scalable, and the way it scales up is the number of blocks, the number of basic blocks you have in the puzzle, and the complexity of the path, and the time, the speed. Well, also you can also have the speed of your tool. You know, maybe you have different tools type. One that is faster, one that is slower, one that is maybe not very precise, like it's bumping a bit by itself. And yeah, so this one scales up very well. I think if we can keep 16, it's perfectly fine. And I think the only thing that I don't like too much is the speed, but like my tool is very slow. But you see it kind of works, right? So that would be the idea, okay? So that you build it like this. Now the first one is fucked up, but I think we can fix it. And the sign on the ground will be smaller or bigger based on the tool as well. So I have to think about it, but I think is okay. Now we need to invent other mini games, you know, for like cooking. I think for cooking maybe we can have the same one for liquids, then one for mining, one for lock picking, and one for fishing. But I think if I already do, you know, one full, I think is good. Let me just show you the difference between the two mini games at the moment. Okay, so this one is made in a very simple way. So is a tool, which at the moment is a cube, but then we can change it, and we can also animate it. Right? We can have an animated tool in the future. That you are moving with your mouse, right? So there is a mouse input in the blueprint, and based on the way you move the mouse, up or left or right, this thing never changes the Z. It's never changing the Z, so the vertical coordinates, but it's only changing the Y and the X. And so you basically move it with your mouse, which is a greater simplification, I think, compared to the previous one I did, which was this one, in which you have actually a ball with physics, which is now completely hidden, so is invisible, and you have this kind of needle which is moving with the ball, but you don't see the ball. So, and now I added at the front, if you see a small arrow that is telling you the speed at which you are going, which I don't know if I want to keep or not, but it is basically a way to, you know. So now this one is a better feeling in your hand, like it feels like it's a real physics thing. The other one is way simpler in the way it operates. So there is no inertia You know, there is no inertia when you are moving, so it's just it feels like your mouse is directly moving the tool, while in the other game you feel that there is some sort of physics involved, and your needle as a mass, you know, and is moving with the mass, with his mass, and so you have to slow it down, accelerate, and if it takes a certain acceleration, then it's very hard to make it rotate. So yeah, so I think that's the main difference, right? That here, if you have to go in a kind of a narrow path, you may mess up easily. While with the other one, it's much easier to keep. Like if I'm here, I have to go back. Well, it's kind of okay anyway. But if you take some acceleration and then you want to stop, like now, is not so. It's a bit. It's slightly harder than the other one. Okay, but I think this one involves much more calculations and physics, and so I don't know if I really want to use this one. Yeah, when you touch an obstacle, you know, at the moment it's giving you kind of a visual. I mean, kind of a sound, right? Like an explosion. Yeah. The lock is looking a bit better, still not great, but I'm making progress. Okay, good. At the moment, as a lock, I only have this, nothing else, which is like 2 circles and a tool. So also this one will have to be fixed, right? But I decided to work on the other one. Yeah, the cube, by the way, is working, and this is make a soup. This is the one with the bubbles. Now, this is actually a kind of a 3D thing. I don't know if I want to do it this way because it's pretty expensive, but I don't know, I think it's maybe okay. So basically in this room you have all the different, you know, small mini games. That we can do. Now this is called Forge, but it's actually not the Forge. It's called Forge, but it's not the Forge. Okay. Okay, so this is just as a summary of what I was doing, right? That is the summary of what I was doing. Now I would like to continue working, and in particular I want to fix this. Let me see if I still have. I don't have it. I don't have it anymore. Okay, anyway, I was working a bit in Blender, and I was trying to see if I put this checkerboard just to know, you know, just to define the sides of the, to be sure that I was matching the connection intersection points between the two boards in the proper way. Hello David, thank you for the follow. And so we need, so, and here are the other tools, right? So I have this one and I have this one, right? I'm making them all in the same file, which I think is okay. So what we need to do, we need now to fix this one, because this one does not have the back faces, right? So some faces, as you may see, now it's not very easy. I don't know if you have a better way, but for me it's not very easy to understand if those faces are back facing or are not back facing. I really cannot see it easily. I don't know why. I think I found one day something that was called backface culling here in the list, but I cannot see it anymore now. And it was a way to set, maybe because I have to go under face. I remember it was in edit mode, Because my problem is that some of these faces are, maybe if I put a material on it, it will be easier. Maybe if I put a material on it, it will be, because you see, you have this transparent mode in Blender, which is called X-ray, which allows you to see through. And basically, where you see through means that there is an hidden face. I don't know. I still don't understand. How can I say where is the direction of my normals? I mean, if I had the normals, that would be much easier. Can I show the normal of this thing? Face data. No, I mean, for sure it's there somewhere, but view, toolbar, sidebar, tool settings. What is tool settings? This thing at the top. Okay. Which is the same that I have here, right? Tool. Yeah. And frame selected, view frame, local view, cameras. Cameras I don't care. Viewpoint, navigation, line view, aligned region, play animation area. That's interesting. But as you can see here, you know, my object, which is like this one, right, is a bit fucked up. So he has some faces on this side, some faces on this side, but not in the opposite. So basically, we are missing the faces inside the small corner. So we're missing the faces, yeah, at the opposite of this one. So if I copy all of this, I think this could be what I need to do, right? If I copy this, I have 4 faces selected. I do a mesh duplicate, and wait, and now I have 12 faces. Now I do B. What is it? B. How many faces I have selected now? I have 8 faces selected, right? So 4 are facing why I cannot select this one? Four are facing this way and 4 are facing the other way. So at this point I need to do mesh, normals, flip. Okay, so now we will have now we will have faces on both sides. My only issue is, how the hell can I see that? How the hell can I see that now I have both faces if I don't have a way to see the normal of the face or to see it transparent? I mean, let me check this back face culling, which is something I need. Blender 2.8 back face culling. How do I select it? How to enable? Wait, no. Material level. Blend mode? No. It's in the viewport, boys. It's in the viewport. Viewport, backface coloring. I think enable face orientation from top right in the viewport. Enable face orientation in the top right of the viewport. So the first one is object types. Okay, the second one is gizmo. The third one, oh my god, what is this thing? It is huge. Okay, viewport overlays. I can have text, extra bones, geometry, face orientation. What is face orientation? And what does it tell me? So the blue, no, red. So now I need to know what the color is. Ah, they look at the X. I see. This face looks at the X axis, and so is red. And this one why is blue? It's not pointing up. I know. To me, it is so confusing, bro. In 3ds Max was so easy. You could just see it. If he's not there, you just see nothing. It's transparent. Why we cannot have it this way? Why you cannot have it this way? I have no idea. Why so hard? Why must be so hard to know if you have a face on one side or the other side? I don't get it. Red is flipped. Red is flipped. No, but I made it flipped because I didn't have it that way. So the fact that it's flipped is okay, as long as you point, like here, for example, I have this one which is flipped, yes, because he has to point this way, and this one is, and this one. So if I move, you see, so there are two faces, one looking at me and one looking the opposite way, and it is exactly what I want. So in this case, I have two, but if I select this one, you see, there is only one. There's only one face. So actually, at the back, it should be fully transparent. I don't know why. I don't know why it's so complex. Edged faces, hidden wire, mesh vertex group, edge length, edge face, face area, normals. Oh, show me the freaking normal. Sides 1 meter. Oh, okay. So this is a one way. Okay, this is one way to see it. Yeah, but I need it only for the selected ones, though. I need it only for the selected ones. Well, one is too much. Well, that's an improvement. That's definitely an improvement. 0.2. But I need it only for the selected ones. Not for all. Because, you know, if you select and see the normal, it's so easy to know. But anyway, in this case, it's also pretty easy to understand now, because you see that you have two normals, 1 and 1, 1 and 1, 1 and 1, 1 and 1. So all this is okay. Well, you can see here that you are missing all these faces. All these faces are missing. So that's pretty cool to see. Yeah, so this solved my problem. Still, I want to see the freaking face culling to item. I'm sure there is a setting in the viewport where you can select red flip. Red means not two faces. No, it's two faces, because here you see, if I turn that on, if I remember, where is it, face orientation, like here there is a red one, you see there is a red one, but actually I have a face on the other side. So it should not be, for me, this piece is okay. This piece is fine, because he has faces on both sides. This one is not okay, because the problem is that if I turn this, okay, I think I understand what you mean. Wait a second. I think I understand what you mean. So if I turn it, if I flip it, it will become blue and they will look the right side. No, but now these ones are red. What the hell? And you see that the normals are wrong. So the normals are, I only have normals on one side. So it was correct the previous way, like this. No, that setting of face thingy is not helping me at all. It's just making it more complex. What I need is the normals. Normals are good, but where the hell is this back face culling settings? Bakes fiscally in all view modes. You cannot need many for export. Many shiny thingy. Bakes fiscally need so like to now material is now per material and checkbox is in material settings. So maybe without the material it doesn't work. Let me go in this guy because this guy has a material. So the big box actually has a material. So can I material bake face scaling? That's very good. Okay, that's exactly what I needed, boys. Yeah, but I can do it here as well. You see? Oh, finally. Okay, so I just need to click on this thing. Settings, where am I? Just to find it again. Material properties. So I think this is a global setting. So you see that now this one at the back is transparent, so it shows very well that he has no faces. While on this side, it shows that he has faces. So I know that here I have to... Let me just see if I remove the transparent mode. It's the same. Okay, good. This is what I needed. So in this case, it's very simple. I see that I'm missing those faces. So I go in edit mode, I click whatever, I select whatever faces I need to duplicate. I go under mesh, I say duplicate, I click, so now it's duplicated but it's standing in place. And then still with those selected, I go to normal flip. So now I have basically duplicated my faces and I have them on both sides, right? And so now if we re-import it into our game, we will have it correct. So okay, pretty good. Now it's not perfectly in line, huh? By the way, I mean I have the other thing that makes me mad is that when you select, you don't select them all. Why when I do B and I box it, is only selecting the one in my face and not the one at the back. So like in 3ds Max there is a setting which is select back facing, right? Select back facing, and I don't know, maybe there is here as well, but there should be I want select back facing on. As you may understood, I'm not a Blender user. Select back facing. So I need... No, I didn't make it yet, but I will have to do it. I didn't make the algorithm yet, but that will be next. I was searching algorithm generation. There are 1 million on the net, but they are very complex. I don't know if I want to, and they are, depends on your problem. So I think I will need. I remember. I read this already. So to backface, I need to go into this mode, X-ray mode. If I'm in X-ray mode, then I also select. You see, I also select the one at the back. So this is what we should do. So GY, right? I think it's okay. GY, I'm getting better at this, huh? I select all, I press G, Y because I wanted to move it on the Y axis, and then I move it exactly where is the connection point, right? Did I do it right? Yes. Whether is that? Because it's in, yeah. Okay, but anyway, it's fine. I mean, it doesn't have to be perfect. So now the question is, which kind of shapes we want, right? Which kind of shapes we want? Which kind of shapes we want? Do you have an idea of the algorithm to use? I have no idea at the moment. But the shapes I want to use are, so let's assume we are in a grid, right? We are in a grid. I think I did this already. I have the feeling I did it already. I have a sense of deja vu. A big deja vu. Okay. But anyway, the shapes, because I need to have my grid, right? It has to be a grid. It has to be a grid. So if I If it's not perfect, it's okay. If it's not perfect, it's okay. Just okay. Let's just do this. The power of paint, boys. The power of paint. You're using Photoshop because you think it makes you pro, but okay, it's enough. I don't need 1 million. I just need 2 or 3. So I think it's too small as a square. Yeah, this is what is starting to make your eyes go dizzy, because the black and the white that way makes it a bit weird, at least on my side. So you start to see the dots where are the connection points, which is weird. I mean, your eyes are getting. So which kind of shapes we want? Because we can have different kind of shapes, you know. So one shape, the easiest shape is the one they already made, which is one line going up, right? That's the easiest. Now I can have a line going horizontally, but I can just rotate this thing. So I think this one will have 2 positions, right? So which is my if I hide this one and show the other one, right? This one, which is 2 lines, I can rotate it 90 degrees, and so I can make it work both ways. Then I have the L, right? I have the L, and the L is the one they already made. The point is that they should always connect to the middle of the square, otherwise they will not be compatible, right? Now another one that I may have is like a V, right? So if I do something like this, so you will have to go up and down. Then I don't know if I can have something like an S. That would not be super easy, because in my boxes, let me see my checkboard. I can start from here and immediately go left. Yeah, but I think I can anyway. I can immediately go left. I can go up. I can go right again, and I can go down, and I can exit from here. Yeah, so like a full square, you know. I think a full square I can do. So in our representation here, it will be something like this. Yeah. So you enter from here and you exit from here. Now, what is the good of this one? Well, the good of this one is that it's a bit annoying. So you have to, you know. Now, I don't know if I want to have, each of these shapes then with a kind of different difficulty level. So let's say that this one, let's take, what I'm doing. I'm selecting something, no. Yeah, so like, for example, there could be the easy version, which is like this, but it could be the more complex version, which is like, a bit like this, where he has like, a place that is very, very, very tight. And so in that point, you really need to be super precise or you will fuck up. Now, how do we, considering they will not see the borders, because I don't think I want them to see the borders. I think I want them just to see a trail on the ground. Yeah, but I think we can have a larger trail and then a very, very thin trail on the ground, so they see that here is harder to go through. Yeah, maybe. Hey Gion, can you think to an algorithm meanwhile? I know it's not easy, but which other shapes we may have? We cannot have anything round, I think, because well, in theory we can make it round. We can have a round thingy. Which other shapes can we make? Well, we could have like this one, but with 4 sides. Well, 3 sides actually. So it could start here. It could go like vertical, like, you know, this way, then this way, then this way. Oops. No, it's not very easy with the mouse. And then exit from here, right? So this could be another variation of the one above, just with yeah, just with this thing. Which other variation we may have? If I do this, well, there could be a simple one which is just going up, going here, and exiting from the other side. Yeah, that would be. It's like the simple version of this one. Like it's similar to this. So like here, 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 and here. And also this one can be reverted, even if the reverting this one is not making any difference. No, it's not making any difference. So it just changes the shape a bit, but doesn't make any difference. Then, is there any other possible shape? Don't tell me to do something like this, because it's not possible, okay? So I need to exit from the sides. So straight line, horizontal line, L in all 4 corners. This one up and down, left and right. So this one can be rotated. This one can be rotated 4 times, 3 times actually, right? To get 3 more shapes. This one the same, can be rotated 3 times to get 3 more shapes. This one the same. This one the same. Is there any other possible shape? Well, yeah, there could be something like this. Like you go up and then you exit from here. You go up and you exit from here. So it's similar to this, with the difference that you go down then at a certain point. Yeah, we can do that. We can do that. Then in the same way, there could be this one. You know. So instead of the triangle, we have the square, but only for half of the sides. Hello, male devman. How are you? Mali or male or mole? I think it's mole. Mole devman. You like puzzles? Yeah, we are building puzzles. We are trying at least. Is there any other possibility? Because I can go straight. The L I have, the straight I have, the other L I already have, the triangle thingy I have, the triangle and then going down I have. Well, I could have in theory this and then this and this, right? And then exit. So it's a mix of triangle and the other piece becomes a square. I don't know if I really want this piece though. It looks annoying enough. I think we can leave without this one. And I think we can have these pieces. So 1, 2, 3, 4, 5, 6, 7, 8 pieces. I think 8 is a nice number. I don't know why, but I like it. So we can have 8 pieces. And we can randomize. Now our problem will be to create an algorithm which is making compatible puzzles. Making compatible meaning that the line should always be respected. So I think, I don't know what is the best way to do it, but I'm thinking that considering a square as 4 exits, 1, 2, 3, and 4, I need to express one cell as kind of a binary, you know, kind of a binary flag of these 4 positions. So I need to know, because I only need to know where I enter and where I exit. I don't care what's happening inside the box, right? So let's say that there is a straight line, or that there is something like this. Oh, sorry, it's not understandable. Or that there is something like this. I don't really care, because I enter from here, I enter from 1, I exit from 3, and in this other case I still enter from 1 and exit from 3. Then I have 2 possibilities, no, and maybe I have another possibility here, which is to enter from 1, exit from 3, but at the end, or I have this one, the triangle, again I enter from 1, exit from 3. So for every, so I just need to build an algorithm that is selecting entrances and exits, and that's it. And then I randomize all my pieces based on what they provide. If they provide an exit at a corner, yeah, because basically we have the corner piece. Hello, William. Welcome. Thank you for the follow. So we can have the corner piece, right? And the corner piece is just rotated 90 degrees 3 times, and you have all the corner pieces, right? Yeah, so let me think which kind of cases we have. We have the corner piece, we have the go-through piece, and that's it. So you have 2 possibilities, right? Right? There is no other possibility, right? Because imagine that I do this, it's still a corner piece, because I enter from 1 and I exit from 4. So the algorithm need to generate a sequence of corner or pass-through. So you can enter, let's say that the algorithm is starting from somewhere. So it's starting from here. What he has to do, he just has to say, do you want a corner piece or do you want a go through? And you can give this weight, I don't know, 50-50. He says corner, okay, then he says which corner. Well, no, it's much easier. I can just say, do you want 2, 3, or 4? Who cares? I can just say, do you want 2, 3, or 4? So you can just randomize between 2 and 4 and choose one. Okay? So let's say that he chooses 4. The only problem is that here I may have a wall, so because my puzzle is extending on the right side. So if he chooses 4, the game is finished. Yeah. So actually, 4 in this location will not be available. Would not be available, right? Yeah, so we need to generate first the available game space, and then we need to generate the available game space. What I mean with that, I mean that if we know that we have 4 boxes only, let's start easy, okay? Let's start with 4 boxes. If I know that I have 4 boxes, and I know that I will always start from the same place. So, and I know that I start from here, This corner is not available, this corner is not available, this corner is not available, this is not available, not available, not available, except from the exit actually, because the exit can go to a corner. So I think that we need to generate the entrance and the exit first. Yeah, we need to know where the exit is and then connect and then find a path from the entrance to the exit, I think, right? And by the way, if you search the web, I did some search about maze generation algorithms, and there are a number. The problem is that can we use them? I searched this already, and the problem is that I don't know if this is the same of what I need. I don't think so, because this one is generating a puzzle. I mean, it's generating a maze which has dead ends, some dead hands. So you get stuck and you have to go back. In my case, there is no dead end, so it's only a you know it's like a road. It's like a single road. And so this thing, for example, this guy gives you the source code, right? But I don't think I need this. So I need a simple algorithm to generate to find a path. Actually, I need a path finding algorithm, right? I need a path finding algorithm, which is given a start and giving an end. I need to know what is the path, what are the possible path or the shortest path. No, I need to know. So if I want to enter here and exit here, there are two possible paths, this one and this one, right? So I need an algorithm that is able to determine. Now the length will be one of the parameters I want to give as input, because the higher the skill, the lower the path. So we'll find the easiest path, right? Now there is one way. Another way will be to say, fuck it, I don't want to generate it automatically. I make a predefined set of puzzles with a specific road. Well, I could also with a specific road, and then I will always use that one. I have like 10 puzzles. The annoying part of the 10 puzzles is that they will look the same. Well, I can randomize the pieces though. I can keep, like, let's assume that we create a puzzle that has, I mean, it's much bigger than this. Okay, so is I'm just thinking, boys. Yeah, I cannot go too close, otherwise it will not fit. Okay. Let's assume I have my puzzle, which is much bigger than that, right? And I create 10 predefined routes. Like one is this, another is like this, another is like this. I don't know. So if I create 10 of them, I don't think that the player will start to recognize the patterns, right? If I create like 10 of them and then I randomize my pieces in the 10 that I created, right? So let's say that I have one which is very simple, which is like this, right? And I start to randomize my pieces. So we start to be like this, like this, like this, like this, like this, like this again, and like this again, right? The player will see, okay, this one is the L, is the L pattern. The player will say, hey, it's the L pattern, that's it. But who cares? I mean, if he sees there is a specific pattern, because well, I think the one point is scalability. If I create 10 puzzles, I cannot scale up as I want. If I create an algorithm that always works, then I can scale these up even more, right? And then my algorithm will be smart and will just go through this as he wants, and continuously create different puzzles. Yeah. At the moment, what I'm thinking to have exactly 16 blocks, like I have now here, which is the 16 blocks that I can fit into that, because it is actually 4 blocks, and I can fit like another 4 here, another 4 here, another 4 here, so I have 16 blocks that I can play with. And certain games will be only 1 block, other games 4, other games 8 or 16, right? So I can play with, yeah, but the point is, if I only have 4, or if I have 16, or if I have 8, my algorithm should be smart enough to know that it can only use the first 8. Otherwise it doesn't scale up well. Okay, I don't know, I'm thinking if I want to invent this, or if I should search the web for a solution already. If something already found this, I mean, already had the same problem, and try to find a solution. But to me, it's pretty simple. So the algorithm, I mean, simple in the algorithm should know how many blocks he has available. 1, 2, 3, 4. Where is the entrance? And the entrance will always be the same. And where is the exit? So if it's only these 4 blocks, he will have to decide which one is the exit, and the exit could even be the same block, so it could be like this, and so you enter and exit and it's done, or you enter and exit and it's done. But in that case it will be a game of 1 block only. Yeah, I think this is the first thing to decide. I think we may scale. I think the idea is to have 1 block game, 1 block game, 4 block game, and I don't know if I want to have 8. 1 block game, 4 block game. Well, I could have 9 block game. Yes, I think this is what we're gonna do. I think we're gonna have 9 block game, or 16, right? So at least you have the borders, which are always the borders, and everything is representable with a kind of an array, right? I mean, it's not really an array, but you get the point, right? I don't have enough space. Well, I can delete this. So the engine, so the algorithm should say, in which kind of game are we? Right? Are we in a 1 game, in a 4 game, in a 9 game, or in a 16 game? And this will vary based on the complexity. So this will be the first choice. This will be the first choice of the algorithm. And then after he has selected this, you will have to choose. You will have to choose the entrance, but the entrance I think we can really have always at the same place. So this is the entrance. This is the entrance. That is the entrance, and that is the entrance. So then you will have to pick the exit. So for the game number 1, super easy. The exit is in the same block. For this one, he has 3 choices. For this one, he has 7 choices. For this one, he has 15 choices. No, 15, 3, 6, 9, 11 choices. Okay, so you will select the exit. And how should it select it? Well, the simplest, it will choose it based on complexity, because obviously if you have an exit, let's say that you are in this game, okay, the 16 game, and you have an exit which is here. Well, it is not true that it makes it simpler, because even if the exit is closer, you may still have a very long path to reach it. No, because I was thinking that the closer exit is automatically a simpler puzzle. Like if you have an entrance here and exit here, is automatically a simpler puzzle, but it's not true. Well, actually, because you could obviously go like this. Oops. You could obviously go like this, and so still use all the tiles. Or so yeah. The other question is: should the algorithm always use all the tiles, or can the algorithm also go like this? Or could the algorithm also go like this? I mean, obviously, if the algorithm goes like this, would be a bit stupid, because you could have used the 9 game, right, instead of the 16 game. You could have used this one. So I think that there must be, if you're using the 16 game, there must be the usage of at least 10 tiles. Right, so one more than this. I fucked up. One more than this. Otherwise, you use the 9 game, right? Or we may force that is always using them all. We may force that is always using them all. The problem is that, like in the 16 game, there are not so many patterns, right? Well, actually, there are quite a bit. No, there are so many. Okay, so I think it's okay. In the 16, there are so many paths that you can use to cover all the boxes, and still in the 9, well, let's say in the 4. In the 4 is super easy. I mean, it's like this. If you want to use them all, it's like this. It's like this. I don't know. It's like this. I mean, there is no other possibility. Well, you can choose to use only 2. Yeah, I think we need though. I think forcing it to use all the tiles is not a great idea, because it doesn't scale up, So it means that, like, in the 4 game, it will always be complex as 4, while we could have it complex as 2, complex as 3, or complex as 4, right? So yeah, so I don't think I like the fact that we are forcing to use them all. I think we should just scale the algorithm. Okay, so basically there must be a kind of a snake algorithm. I don't know how they called it, but the snake algorithm is that the snake cannot go in the cell where he already has been. How did they? I just made up the snake algorithm idea, but holy shit. I don't know what is the name. Maybe there is a name for that algorithm, you know? The greedy snake algorithm. What is it? Is it PPT? Problem solving the greedy snake. I don't think I can open a PPT on this PC. Snake algorithm. I cannot open it. Connection. GG. I remember that Microsoft released all the viewers now. I remember there was a PowerPoint view, a free PowerPoint viewer, no? By the way, I don't even know if that PowerPoint will tell me something. Microsoft, what do you want? Reject all cookie. I don't want any cookie in my life. Microsoft PowerPoint viewer. PowerPoint mini games. I don't know what I'm downloading. I'm downloading an Excel file from what? cnet.com. Yeah, I think it's okay. I think cnet.com is not too bad. Maximum we will have some adware or spyware, but I don't think any viruses. Don't install it on C because C is my SSD drive and Microsoft Office. Can you do it? I don't even know which version I got. The greedy snake algorithm. There is also a noise. There is also a sound. Works like a stretched elastic band being released. What the fuck? No, this is not what we need. Wait. Wait. It could be, huh? What the fuck is not going forward? Normalized by the greatest value neighborhood, the higher the B, the more important the angle are maximized. Holy shit, bro. I don't know what I'm looking at. What the fuck? There is a demo. But I don't know. Questions, yes. The question is, what the hell is this? The question is, what the hell I was looking at? Okay. Fine. No, maybe it's not called the snake algorithm, but how can it be called? Can you search it on the web for me? Can we find an algorithm which is searching for adjacent cells, and when it's going through a cell, it doesn't go again to the same cell? That's the only thing I need. Mm, mm, I don't think it's called snake, but I think it was a good idea to call it snake. No? No? How to find a safe path for an AI snake? Okay, this is similar. I've been working on a game which I can complete with the snake AI to get the most apples. The current pathfinding technique is using app pathfinding was nice, but I'm struggling with coming with an effective way to make sure the AI snake does not go from a general to trapping itself. Consider snake can teleport. We are coming closer, boys. Take a look at Steven Snake, the project demonstrating QI algorithm for the game Snake. The project readme is a very nice explanation of the algorithm. The key for the snake to follow the Hamiltonian circuit, a path that visits every square and loops back on itself. Okay, that we can use that. Finding such a path is also known as the longest path problem. If you make your AI follow the circuit, you never trap itself. You have to go as largest as possible, fill in and type grade. If you're lazy, you can stop there. Doesn't ever need to care for it. Of course, you make a snake faster. I will make, okay. The empty screen. The snake move, follow that. Okay. The calculation and the movement can be considered done. For the most. Okay. This algorithm is much better, but still not the best. Since the following original internal secret is possible to find a secret like to take a better shortcut. I think you can complicate grids with obstacles. This can easily complicate on this path. Multiple snakes. Wow, this answer is insane, bro. This guy, I'm gonna to upvote him. I cannot, but just because he's an insane answer. Okay, so I think that what we need is what I call this one, then click on the green picture on the post. Yeah, with this post? What do you mean by green picture? I think this is what you need. Oh. Hamiltonian path. The mathematical field of graph theory, Hamiltonian path or traceable path is a path, an indirected or directed graph that visits each vector exactly once. An Hamiltonian cycle, or Hamiltonian sequence, Hamiltonian path is a cycle. So the only problem with this one is that it returns on itself, right? It's not exactly the one I want, but anyway. It's this guy, huh? Look at this guy. Holy moly. Irish mathematician. Holy, seems that he's thinking a lot. So, example. Oh my god. So you can apply to whatever you want. You can apply to. Did you see the link I sent? No, because in my restream chat there are no links. Let me see if I can see it on YouTube. Um, for some reason, I think your link was filtered out. All messages. Wait. There is a way to set all messages. Did you make a? No, there is no. There is no link. I think. Can you type it like with spaces after dots so that it doesn't get filtered out? Because I think it got filtered out due to kind of a spam, spam messaging thing. Um, hmm, hmm, okay. Doesn't give me the algorithm itself though. Hmm. Ah, you send it on Discord? Okay. Okay. Random path algorithm. Quick follow-up to my previous post, I found the same technique is pretty good at generating organic looking a random path. You simply start with an empty room to keep randomly flying points. Okay, I can look at it, but in my case, I think I have. I mean, it should not be random. It should be working on a grid. You know. Brog. This Brog is okay. Try a demo. Click to add remove anchor points. Oh sure. Oh sure. Yeah, but you see, like I don't need this. So I don't need the fact that it goes in two direction, and then I need just the connection between one point and the other point. And in any way, is the algorithm here? I mean, because I need the algorithm. I need a C++ or something, you know. First, I pre-compute a bunch of disjointed LSX structure and complete one for each possible vertex. Take a look at the code. What is this? I know what I'm doing. It's connecting things. Okay. Hmm. 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 Holy shit. Okay. I don't know. I don't know if it's because it's generating, it's not covering the wall ground and it's generating. So I will need, a way to generate a path of a given length. This Hamiltonian path was looking interesting to me. I was feeling that this one was actually Hamiltonian circuit. Let me search for Hamiltonian circuit C++ or whatever. Hamiltonian cycle, backtracking 6. An Hamiltonian cycle is a pattern path that visits each vertex exactly once. If there are edges between two consecutive vertices of this configuration, there is an edge from the last vertex to the first in this configuration. Yeah, I will need something like this actually. In this form, I think will be enough for me, you know. And then I will translate it into blueprints or whatever. Hamiltonian circuit implementation. You know what? The problem is that to me, it has to be on a grid, you know. A rectangular grid, exactly. So for me, it's a bit easier than that because it just needs to be. Holy shit! We found a guy that decided to do a thesis on this. Enumeration of alternative seeking rectangular grids. Holy fuck. Okay, introduction. We consider the problem enumerating Hamiltonian seeking on a regular grid. The grid graph blah blah 39, which I assume is the number of cells. Yes, it is. The number of times seeking a grid path will be blah blah blah. Okay. One score in terms of regular language. Okay. Representation and characterization. Very very clear. How does it do it? 100 100. No, but the problem is to. Okay, so it's not what I want. I mean, my issue is I want to cover it all without opening points, right? It's not Hamiltonian then, or it is. I need a snake. I don't need a tree. Oh my god, this guy really into this. This guy is really really into this. Some technical details, like if the previous chapters were just not technical, you know. I like this one. Some technical details. Look at what you wrote above, bro. I mean, some technical details. Whoa, look at this. It's not technical enough. Holy moly. Okay, this chapter 4 is some technical details. Let us begin by recalling with familiar concept of combinatronics. This is a familiar concept to you? I don't know, it's not to me, but okay. But anyway, it seems that this guy is not covering it all, and anyway, this paper is too complex for my simple mind to understand, and so it's zero value to me. And it cannot be that complex anyway. Oh my god, it's still going on. But I think we are closer, you know, because I think grade, Hamiltonian grade, shortest distance between two cells in a matrix or grid. Well, find a cost optimized path through a grid matrix in C++. I'm stuck with a problem. I could not find much help online. I need to find a minimum cost combination of number for multiple vectors. The vector size. You know that at the end I will probably design it myself, and that's it. It'll probably be slow and not the best ever, but considering we are working with 16 tiles, I think that as low as I can make it would still be pretty good. That's how you feel when you talk on the dev channel? Okay. I don't know if we have unique pad. A robot is located at the top left corner of an end grid. The robot can only move down or right at any point in time. Hmm. Hmm. Exactly. That is my problem. A robot is located in the top left corner. A robot can only move down or right. Only down or right? No, down or right is pretty stupid. It should also be able to move up and left. But what? It is a contest. Okay, it is a contest. I had to write C++ code to find out. But we are close because you see, we are finding stuff that is pretty close to what we want. Cheapest padding graph. I mean, I don't really like. I don't really need cover grid. Algorithm. Algorithm to cover a grid. Find the most efficient path to cover an area from multiple starting locations. I'm looking to design an algorithm for a problem I have, and I was hoping to answer one. In my picture above, the grid in an area is explored by circles. Each cell is a unit of words. Super simple. Hmm. This Hamiltonian thing, it seems to be the way. I have a grid of some width and height, where each can be three possible values. You may select any number of green cells, which cover all the red cells, in a pretty many square. Cover as many red cells as possible, using as few as possible, do it as fast as possible. Hmm. I'm really amazed when people answer like this. So they are creating like a white paper just to have an answer on Stack Overflow, which is insane. Hmm. Okay, I'm starting to lean towards doing it myself, huh? Mine is just a simple path. These problems are much harder, I think, because they are trying to do like coverage, you know, coverage of space and escape from grid. Assume you are given two-dimensional grid, rows and columns, and 0 denotes an empty cell, 1 denotes a cell that contains a plant, 2 denotes a cell where you are standing initially. You can move in the Latin shell if the cell is empty, and 2 cell is inside. In other words, if a shell is empty, you can move in the 4 direction, up, down, left, right. You cannot move out of the grid. Your task is to find the length of the shortest path for each one of the boundary edges. Oh shit, look at the code. There is no solution though. There is a problem with no solution. Why? There is only the problem, but there is no solution. There are 886 submissions of solutions. Anyway, it's pretty similar to this one because it's a skip. Yeah, they are focusing on finding the shortest path. For me, will be I think I would just make it myself. Fuck it. Grid embedding algorithm. Okay, I think I give up on Google at the moment. Okay. Fuck it. Okay, so we try to solve it ourselves. Okay, so I don't know. I think that's probably possible. I mean, there is something online that could help me, but let's just try to solve it ourselves. So the problem is to decide the level of freedom we want to have. So like if we always want, so if you want to find a path, so to me the easiest will be to have the number of cells you want to cover and to randomize. Yeah, I think to me, I would like to have as input the number of cells to cover. There's only one input. Number of cells, right, to cover. So that's my input. So I only want one input. And the start. And then he can put the end wherever he wants. And he can use any cells he wants. So let's say, for example, that I'm using the four cells game, right? The 4 cells game, I can say I want to cover 4 cells, I want to cover 3 cells, or I want to cover 2 cells. So here it will be ranging from 1 to 4, and to solve this problem will be super easy because if it's 2, I can just select this one or this one, right? And the problem is solved. If I say 3, again, it's super simple. It can be this or this. If I say 4, I cover them all. So let's say in a case of a 4 cells game, the algorithm is super simple. Now, if I use the ninth cells game, right? I think that the minimum number that I want, so let's say that my input is 1 here, is from 2 to 4 here, right? And here should be from I don't want 3, I want 5, right? I want to start from 5, otherwise I will use this other game, right? Because it doesn't make a lot of sense to me to do something like, well, in theory it could be, but I could do something like this, which is not allowed in the 4 cells game, but it's not really using, the complexity of this. Yeah, and the overall complexity anyway will be similar to the full set game when I have a 4. Yeah, exactly. So I don't want, yes. So I want to start from a 5, right? Otherwise the complexity would be the same. So fuck it. So I want to start from 5 and do what? Just a second. There is a small dot on my screen. I don't know if it's. No, it was actually a piece of. It was actually a pixel. So we can solve it from 5 to. So minimum is 5. 1, 2, 3, 4, 5. Then it can be 6, 7, 8, or 9. So it's from 5 to 9, right? That's the input. And so in the same way, here will be from 10 to 16. Okay, so that's, at least we understood that, which is pretty easy. So the algorithm needs to have this as an input. Now, how can it work? How can it work to determine which cells to use? Well, if it's 5, I mean, is there a way I can mess up? Is what I'm thinking. Is there a way I can on this one is impossible to mess up, right? On this one, can I do it wrong? Can I do like 1, 2, 3, 4, 5, and I'm not at the border? Well, you know what? But I don't think I care that I'm at the border. But it's pretty simple. The algorithm can just check if I'm at 4. If I'm at 4, I have to choose the 5th being the border one, right? So I can randomize the direction. So I'm start from here, then I randomize, purely random, 50-50, who cares? Then I go here, then I randomize 50-50, who cares? Then I randomize 50-50, who cares? And then when I'm the 4th one, right, I just need to have a border one, right? If I'm not in a border one, I have to choose the other one. So I think I need to know which cells are border and which cells are not border. But yeah, I think that's pretty easy. Now the problem will be here, because here I think I can really mess up. So I can find myself in a position where I cannot reach a border. Like if my algorithm is telling me that I'm at 10, well, actually, I can also find myself here in that position, because if I do 1, 2, 3, 4, 5, 6, no, it's impossible, because you always have a border somewhere. You always have a border, so you cannot mess up, right? 1, 2, 3, 4. 5, I have it. 5, I have it. 5, 6, I have it. So the more I paint, the more I have borders. So this one you cannot mess up. So this one will work all the time. I can just randomize and then pick a border one when I'm at the 4th position, at the next to last position. So if I need to generate 9 at the 8th one, I will try to find the border. Okay, fine. Now the problem is on this one, because on this one I think I can mess up quite a bit. The point is that I need to generate 10, minimum 10. So it's 1, 2, 3, 4, 5, 6. Yeah, the problem is that I can mess up. Yeah. Here I can mess up big time, because I can. Imagine I go like this: 1, 2, 3, 4, 5, 6, 7, 8, and and I need to do 10, you know? And so when I reach this one, I'm stuck. I cannot go anywhere. I don't think that this may happen in this game, right? Can it happen in this game? If I do... How can I stack myself here? If I have to do 8, if I have to do... Well, yeah, I can. I think I can stack myself if I do something like this. 1, 2, 3, 4, 5. And then I need to do a 6. Yeah. So I can already get stuck in the generation. So actually there is a kind of an algorithm also here. Because I can reach a point where I cannot... Well, I can exclude the middle, maybe, from the beginning. Because how do we get stuck? We get stuck with when my snake is very long and I close myself into a corner. So like this. Here I'm closed into a corner, you know. So the problem is, so the mistake, so if I have a 9, right? And when I'm here, I decide to go down. I think here the solution of the problem is the centerpiece. Because when I'm here, I still have all the possible solution in front of me. But if I choose something stupid like this, then I will never be able to do 9 again. Right? So I think the issue is when I'm in the centerpiece, I think I can have different algorithms for different puzzles. Like the 4 is super simple. The 9, I just need to know that when I'm in the middle, when I reach the middle, and I have a number which is greater than 5, well, in all cases then. So I should never, no, when I'm in the middle, I need to circle around. Otherwise I will stuck myself. When I'm in the middle, I cannot do this. Unless is 1, 2, 3, 4, 5, 6, 7. Yeah, if it's 6 or 7, it's still doable, but you know what? I think I can just test all the possible paths and see the ones that are working. So like I can randomize the first 2. I can randomize the first 3. Yeah. I can randomize the first 3. The first 3 is no problem. But then after the third, assuming that the third is in the middle, I need to test the possible path to solve it based on the total number of cells I need to cover. Yeah, but I think there must be an algorithm somewhere. Now I think I understand it better. I want an algorithm that is randomizing paths. Okay, so it's randomizing algorithm randomize path on grid. Exactly. Similar, very similar to this. Very similar to this. I need to find a path that requires an NN matrix without loops and deadlocks. Yes. For example, I have a grid of 7, 7, and the start the origin point. Exactly. My problem is I don't know how to create a path with required length, fast and avoid loops and deadlocks. In this case, we can solve this with recursive backtracking. Find path of length and starting point. Okay. Track visited state, so we don't touch cross. Mark visited. So for each cardinal direction in a random order, for each cardinal direction in a random order, check if there is a path of the desired length in this direction. So path extends, length start point direction. Okay. What is doing? Proceed in the given direction to find our next point. Point start current direction. If point is out of bounds or if point is already visited, return no. Okay. Avoid touching crossing paths so far. For each neighbor in a tree forward, left, and right points, and the neighbors within the bounds already visited. Yeah, so he's looking around. He's looking in all the positions around it, right? And then is marking this point as visited. Okay, you can keep it in an array, in a simple array, right? Time to bubble back up. If remaining length equal to 0, if the remaining length equal to 0, return path. So in this case, we found the right path. I can make it a bit bigger in case any of you is trying to read it. If we didn't reach an endpoint, for each turn direction forward, left or right or current direction in random order, okay, search for a feasible solution for the smallest subproblem. So path extend remaining length -1 start point turn direction. If path equal to null, continue. Extended path include this point. Such pattern. Right. So what it's doing, what I think is exactly the thing that I was creating, right? What this algorithm is doing is pretty simply to say start here, then go. I fail because it's not long enough. So backtrace 1, see if you have any other option. No, I don't have any other option. And so backtrace another one. Yes, I have another option. And then continue from there, and then boom, boom, and then boom, boom. So it's testing. So it's basically going in a direction, finding a blocking point, and then coming back, right? And then coming back, so backtracing and trying the other options until he finds a possible one. Okay? And when he finds a possible one, considering it's random, I think that would be good for us. Now, the only problem that we have in addition to this is that we need to find one which is ending at the corners, at the borders of our board. Which are still not fully convinced on. So do we really need to finish? Do we really need to finish at the corner? I don't think so. I think I can place. I don't think I need to finish at the corner. I think I can. Oops. I think I can finish here, and based on the direction I'm coming, I can place my end marker. Yeah. Okay. I think we are good. I think that algorithm is the good one, which it was what I was thinking. So it's basically backtracing all the possible positions, right? How do we want to do it? Do we want to do it in C++ or do we want to do it in blueprints? I think probably in C++ would be a bit easier, right? Because otherwise I need to do... I think in C++ would be a bit easier because in any way, yeah. Does this thing have a name? Because if he has a name, you know, I think this is exactly what I want to have. And maybe there is someone else that did it the same way. So he calls it recursive backtracing. I think to me it's clear enough anyway. I think to me it's clear enough. The only point would be how to store. Well, to store it is pretty simple. It's an array. It's an array x and y. You know, so with two dimensions. It's a two-dimensional array, and then we flag. You know, 0 or 1 if it's getting filled or not. So this mark visited is pretty simple. So we just mark it as 1 when it's visited, and we, yeah, I think so. Right? I think we can do that. Should I do it? Let me think. What is the best way to do it? Should I do it? Do I have a simple way to do it? I don't have a simple. Well, I can use this project. This project is not C++ though. I can. No, I think we can use another project. Another simple C++ project, and code it in the. I think any of those, like third-person C++. I prefer if it's an Unreal Engine project because I can use, you know, T-array. I can use all of that automatically, so without too much trouble. By the way, I think I didn't add in the calendar. I didn't add in the calendar the plane shift calendar, the fact that I'm streaming. Today is the 8th of February. The last stream was on the 22nd of January. Really? Long time ago. No. I think it's a long time ago. Sorry, I'm on the other screen. 1 second, I'm just checking. Yeah, the 22nd of January, exactly. No, there was also a 2nd of February. Why don't I have 2nd of February here? Ah, yes, no, I don't. Unreal Engine, yeah, I have it. Today is the 8th. So let me add one event just because I want to keep track, you know, also in our calendar of the fact that I'm streaming. Just because it's nice to have it. Okay, I added it. So what I was saying, yeah, I think we can use this one, right? We can use this third-person C++ project. Now, what I want to do, so let's close this one for a second. I don't want to have 20 projects opened up. Yeah, save everything. We can delete if needed. Let me just check if this one is already compiled. We will just make like a button, like I'm pressing something, and we will call C++ function that is doing the generation, okay? It will be done client side, but I think it's okay. We don't have any issue with But this is interesting. I think we found a way I think I understood the problem. I think we found the scalability 1, 4, 9, or 16. I think we found the pieces that we want to put on. So I think I'm pretty. I think I understand what I want to do now. I think I understand what I want to do now. What is this thing? Okay. This was a test for me on animations or something. But I think it's okay. I think it's okay. We can use this one, and we can. There is a third person C++. I think we can create. We can create a blueprint utility class like I did on the other one, and we can call the blueprint utility class upon, I don't know, pressing. If I open this, it will not open, right? Third person C++ character. This character I think is derived. Yes, exactly. So if I open this one, because anyway we will call it from the blueprint, right? We will call it from a blueprint, but the code should be C++ for speed of execution. So let me see what we have here. Actually, I have some stuff. I also have an item. I have a PS item actor. I have my third person C++ character. Okay, that's fine anyway. We are not gonna use any of that, but so let's add a library. Okay, so a library for our. So I think I can just copy paste it from my main project. I think we have under utils. I think we have under source real utils. I think I have a BHP. Yeah, this one. BP utils.c++. So let's just use this one. And let's copy it into my third person C++. Let's put it just here, is okay. And these two classes, I want them here. Now let's just check. So I don't need any structure at the moment. I just need. I can just keep one function. Yeah, let's delete all of this. Now the problem will be the outcome. The outcome, what it will be? The outcome will be an array with it will be an array with the I have to think what would be the outcome, but yeah, it would be anyway a T array, and I think it can be a T array of int, right? So it's a T array of int because and this will be called like generate puzzle, whatever. Let's call it generate puzzle grid, and the input will be, the only thing I need as an input is the type of puzzle. So the maximum size, the puzzle size. Well, let's say I need x and y, but let's call it dimension size, puzzle size. Let's call it puzzle size, and then I need the path length, right? These are the only two things that I need. as an input, and then here PS Unreal. I need to put this one here. And then here I will have the same signature, just this time. The difference that this would be a util. I don't know if I can return null on TRA because sometimes it's a bit annoying, but I can return just an empty one. No, it doesn't like it. But anyway, all the rest I can delete. Okay. So I think I need to generate. I don't think I can compile it like this. I think I need to generate source file because it's generating the dot generated thingy. But let's see. If I do F7. I don't know if he's smart enough and he's doing it automatically, or if I need to. Someone is calling me. But no time now. He's running, so he should be compiling something, hopefully. You say it's failed. Wow, nested containers are not supported? What do you mean? Ah, we have seen this already. No, but sorry, but can I just do why I need to do that? Can I do this? But I think I need to generate no, I cannot. We solved this problem already one time. The way to do it was to create a structure, and that structure inside of it had another array, right? This is how we solved it the other time. Because you cannot have an array of an array in as a replication object, but for whatever reason. But I think we did this already. We did it. I remember we did it. I'm pretty sure we did it. There was I don't remember if we did it here or if we did it somewhere else, but maybe we even did it here. There was a T array of t-array of a struct, and that struct was just containing one value, which was one array. Now the problem will be how to navigate it easily. I'm searching, so I'm on the other screen. I'm just searching what the people are saying about someone is trying to use a flattened array, but I don't understand exactly what they mean. Like, do you use an array with two values, but is not I don't understand what these people are saying. Yeah, people are working on a struct. So they're putting a struct inside of it, and then inside the struct there is another array. So that's what they are doing. I think we should do the same. I don't know why it's so hard to do this, but so let's call it puzzle f puzzle column or something like that, and there will be just one property, which will be again an int. I think we can use an int, and this will be like cell or whatever. No, sorry, this will be a t array of int, right? And so what I can do, I can then say that this array is an array of this, so that I can have a number of puzzle rows. Maybe it was better if I called it rows, but a number of puzzle rows with inside of it a number of columns. And I think that this way you are like circumventing the problem. I did it already in the past. I did already in the past. Yeah, but I think this backtracing idea is a good idea. I think it's the way we should do it. And then here we will have the code that we have seen. The code that we have seen here. What is it? Yeah, this kind of code I think is the logic is exactly what we want to implement. Now, yes, we have to say. But I think this one is. Yes, obviously, it has to be the same. And then I think that here we can put T array of it should do it, right? It will just return an empty one. Okay, he succeeded. So now the point is this algorithm here we should somehow make it ours, right? So this guy has two functions. One which is returning the path, and this one which is the recursive function which is inside of it, which is actually backtracing to see if forward tracing and backtracing to see if there is a possible solution, right? And then here is, let me just see what it's doing. Finish and return the path, because we don't have a structure to, well, let's say that the first path that we find is I think for us is good, right? So we don't need to find a number of, we just need to find one. So let me just understand what it's doing. Mark visited for us will be just turning a specific row and column of the array as valid, okay? But when you backtrace, yes, because it's true or false, yeah, so exactly, so that will be easy. So that for us is, so let's create this function first, which is the most, the simplest of the functions. So this mark visited, should we put it here or should we put it in another class? Actually, the best would be that this function stays inside a class. I want to create a class, otherwise it will be a mess. I think I can create just a class which is called like puzzle game or something, and I don't think I need anything in this class apart from the mark visited, right? Which I don't know the start point, how to model it. I think to me this can be like a vector 2D, right? That we just call like x and y compared to our grid. I think it would be okay, no? To have a vector 2D on this one, and then the complexity is on this one, on the path, because the path will be the sequence. It can be a linked list. It can be a linked list of points. Yeah, it should be a linked list of points, I guess. Yes. Okay, so this one will be a vector 2D. Right? Can I have vector 2D? Vector 2D where I'm setting the x and the y equal to, well, it will be a float, so it's a bit stupid to do it like this, but anyway, it's okay. I think it's fine. Or I can have just, I think there was, I think there is something that is called tuple, tuple, I don't know how to pronounce it, which is basically a pair. I think there was also a t-pair, right? There was a t-pair. What was the t-pair? T-pair was, I don't remember the difference between t-pair and tuple, but I think you can have a t-pair like this, right? So there is like your x and y. Let me just check what is the difference between t-pair and tuple, because I don't remember. T-pair. Great documentation. Okay, so it doesn't tell us what it is. But type def to tuple t-pair is basically the same. I don't know really what is the difference, but I think it's okay. I think we can have our t-pair of start points. Now the length is fine. So let me make this mark visited function. So inside this class, we will have a function. I think everything will be public, by the way. I don't think we need to go crazy on that. This can return a boolean. No, it can return void. We don't need anything here. And there will be this this t-pair, right? This t-pair, whatever it is, which is basically the coordinates of the cell. Let's call it cell. Maybe it's more understandable. Is our cell, and then we will have a boolean which is mark, right? Mark or not. And do I need the class to be a U class to use t-pair, or so if I put it here, does it like it more? No, it's the same. Argument list for LS simple t-pair is missing. So I need. It wants me to specify t-pair int. Otherwise, it doesn't know what is it. Okay, I think that's what he was annoyed about, because he likes it here, but he doesn't like it there. Okay, so I have my function here, and this mark visited I think is okay. Now we need to put this. So then we need to put this. Yes. Now the path. What will be our path? Our path should be should be a list of coordinates, so a list of t pairs basically. Yes. I can also make a structure. I can also make a new structure. Just call it cell, and so how do I? Because the list I will need to. I think there is a list. I think there is a t-linked list something. Oh wait. I think there was a linked list, t-linked list. Yeah, t-linked list. Yeah, the only point is if I can do a t-linked list of a pair, but I think I should be able to, right? If I do a t-linked list of my pair intent, yeah, I think is okay. If it's okay, I think we are fine. Okay, seems he likes it. Now this thing will be our path, right? And this thing will be our puzzle game class, and so here we will have the same. Why wants to have a path? Return by the extend. I'm a bit confused. Is returning is it creating a new path for every recursion? Because I think it should, no? Or is just going down and then backtracing? So it's going down, is backtracing, and if he's backtracing, he's trying another option, and if he finds, I think he's using always the same path, by the way. Yeah, I think he's using always the same path. So our point will be again this. Wow, direction. Why we need direction? Direction. Current direction. He needs to know because he needs to give it to the subfunction. Okay, so the subfunction needs to know if he's going in a specific direction or not. So I think we can have, I don't know, direction. I think we can have just a number, or we can create an enumeration. I think we can create an enumeration like up, down, left, and right, something like that. Why not? I think we can create just an enumeration. So can I put it inside of this? Should be possible, right? So let's call it just direction, and this one will have up, down, left, and right. I think he wants much more for enumerations in Unreal. He wants like meta, the description, the name, the friend of the name. He wants a lot of stuff. We just open up another enumeration that we have. I think we have an enumeration. No, we don't have it here. I can open up any. Yeah, for sure it doesn't like my enumeration. Why doesn't it like this? Let me find where did we create enumeration? I think like here in million cases. No. We create it like this, but I think we have the Unreal Engine way with the meta tags and all those tags. Where do I have it? Wait a second. I think I have it under PS character. Maybe I have it. No, we only have it like this. Well, first of all, I missed that I placed this and not that. I think it should be okay. Right? I think it should be okay. He wants it all uppercase for whatever reason. No, I don't know. No, but it's okay. I think we can just have it like this. I remember there was a more complex syntax for like the meta tags, names, and stuff like that. But probably it's only if it's a Unreal Engine enumeration that you want to see in the blueprints. Otherwise, we can just use it like this. So direction will actually be our puzzle game direction, right? Then what we are missing? We are missing mark visit. Okay, so we need to put this inside our puzzle game. This extend, right? We need to put it inside of our puzzle game. And extend, we don't have it yet here, so we need to create it. And this will be, we need to declare it, I mean, and we put it like this, right? New direction, I think I have to put it before, otherwise it's getting annoying. Otherwise it doesn't like it, because it's not declared. Okay, so now we have this one as well. Now let's try to solve this part. He's saying for each cardinal direction in random order. Now excluding the one that we are coming from, no? No, because here we are at the beginning. So, but if you are at a corner and I randomize going out of the board, where is checking? It's checking in here. Okay, so here I can really go through a random direction, so I can really randomize between 1 and 4 basically, right? Okay, so I think we can randomize. We can just use random. Random, I think, is in random order. I want it in random for each cardinal direction in random order. So it's not just a matter of randomizing the number. It's also a matter of how do I randomize how do I randomize in a random order? So I need to randomize a number between 1 and 4. I need to randomize a number between 1 and 4, but I don't want to generate the same number twice, right? So, or do I put it in a temporary structure and then I remove the, yeah, because he has to choose it between, is there a simpler way? Randomize order. How do I randomize an order in a random order? Randomize. I think the easier will be to put it, to have a small array with the 4 directions, because I think I have to do the same later on now. Yeah, I have to do it again here. I have to do the same thing here. So, yeah, so to me it's pretty simple. I just create, I just create an array with the 4 directions, an array of int, right? Well, an array, at this point I could do it in array of direction. I can create an array of direction, and I put in this array of direction, how the fuck do I do it? I just put all the I don't remember if I do it this way or that way. It doesn't like our direction. Why? Why doesn't like? Why doesn't get my down and up and such in the? I'm still parsing it, I think. No. I mean, it's a enumeration inside of puzzle game, so it should work in theory. Okay. It really doesn't like it. Because it's inside, and so I have to do puzzle game direction. Okay, because it's inside puzzle game. Oh my god. Okay, I understand. Okay, because is inside this, is inside that. Okay, that's fine. I mean, I don't really like it, but it's okay. But can I add directly for values here? Down, so up Can I create it like this with the 4 values? Does it like it or no? You want me to... It's not smart enough, huh? You want me to do it like this? What the hell? How do I create it? Boys, help me. How do I create a T array from a set of values? How do I create a T array from a set of values? Should I do init? Or should I do the... I remember there was a way, you know, to do it just with... brackets, no? Just with the brackets like this? Ah, yeah, with the brackets I think it does it. I think with the brackets it likes it. Because here the point would be, I can for, you know, this directions array, I started from 0 anyway, right? So and I can select a random so I need to select no, I think I need to do a while this is not empty, right? Because I would like to like select one and then remove it. So like instead of doing this, well, I know it's always 4, so I can just do you just have to go like 4 times. And then for each I will pick one direction and remove it. Now the point is that I need to randomize it. So I need to have a random integer. I think there was a function, right? Which is the random integer with a max. I don't know if it's inside a specific function or a specific library, but random integer, I think there was a random integer. Where is it? Come on. Random integer. There is for sure a random integer, but I don't need this. I need the C++ version of it. I need the C++ version of this. Random range. I can also do random range. It's okay. Rand range is available, or rand range. I think it's inside some freaking. Why doesn't it tell me where is it? fmat. Okay, so if I do fmat, and then let me see what we have here. I think fmat should be available. Fmat random range. Please give me the list. Doesn't do it. It's scanning a lot of files. It's scanning like a boss. What? You see the bottom left? How much stuff is scanning? I think fmat. I don't know if he has. I think he has. I don't know if he's automatically included or. I don't know if it's automatically included or if you need to. He's scanning 1 million files. fmat. I'm just checking if when I used it, if I included any other. I don't think so. No, should be automatically included from the core minimal. So it just not giving me any hint, but there should be an fmat random range and also an fmat random integer or rand. No, rand integer doesn't exist. There is only a random range, and random range rand range. Yeah. Anyway, is rand range. He's not seeing it for whatever reason, but it's like this, okay? So rand range, we go from 0 to 3, right? Included, and then we have our random number. Now, what we want to do, we want to take that particular array, that particular direction, right, and then remove it. So I want to get a direction out of it. I want to get a direction which is equal to my directions of my rand, right? So I get a random direction, and let's call it current direction. I think it's fine. And then what I want to do, I want to remove that direction from the array. So I will do directions. I think it's remove. Yeah, I don't know. Visual Studio is just going crazy. It's not collaborating. But it should be remove of this rand number. So I will just remove from the array the particular random direction that we just selected. So the array starts with 4 elements, and then after one run, it will be only 3 elements, okay, and so on. So then he wants to, okay, then this path for us is a linked list of a t-pair, right? So this linked list of a t-pair is doesn't like this for some reason. Okay, anyway, link is the t-pair, and we call extend, and then we have our current direction, which is this one. So this will be a direction, which will be our current direction. Okay. And then it's saying if the path equal to null, continue. Yeah, now this null, I don't know if we can have a linked list returning as null. We will have to check, but basically I think we can do something like if is empty, because yeah, it doesn't like it, you see. So it doesn't like an operator of the linked list equal to that. So I don't know if there is like an is empty. I don't know why my Visual Studio is getting so annoying, but maybe because there is all this shit here, and so it cannot really parse all of this. It could be. Let me try to just remove all of this, and so it doesn't get confused, you know. I think there are too many errors, and so it's getting confused by the errors, and it cannot actually compile. I mean, use the visual aids. Hello, people. I see more people are joining. Someone is connected on Twitch. Someone is connected on YouTube. At the moment, we are streaming both on YouTube and Twitch. And yeah, the majority of people are on YouTube, but it's fine. If you have any questions, you want to know what I'm doing, just ask. Don't be shy. Let's keep it, interactive as much as we can. Bad command or expression. Fuck, I left something here with a little. Okay, this is probably why it was not very happy, There was a bracket, an open bracket here in the .h file. And this was not making it for him. Okay, so let me see if I can do this one equal to null. No. Let me see if I can do is empty. No. I can check if next is null, maybe. Can I do the pointer of this if it's null? Doesn't like it. Because the only way for me to know if that list is not valid is, or I return it for as a reference in the signature of the method, and then I just return a kind of a boolean, or I can check if he has any elements, if there are any elements there. If I do next, and next is an element, I think it will tell me if the problem is that this next will already fail. I think if it's not. Okay, well, let's try like this. So basically we need to know if this returned as an empty element. I don't know if the linked list is the best one to use in this case, but it was the first one that came to my mind. I think it's link after, add this element to the linked list. Add this element to the linked list after the specified. Yeah, so I think it should be this way, right? And starting point is a pair of int. He wants the pointer of this. I mean, he wants the address of this. You don't like it? I mean, it should be a t-linked list t pair. You want this to be a pointer to... Okay, I understand what you mean, but if I do it like this, so he wants to have the linked list should be a pointer to something. Okay. Should be a pointer to something. And this means that my start point no, it means the address of that. What do you mean? So link after needs link after wants t-linked list pair int pointer. Why? I'm a bit confused now. I'm a bit confused about the t-linked list then. So t-linked list is there an example? I think I used it already, by the way, in many places. I used it in crafting so much. Let me just go 1 second to work manager. I think I used it a lot. No? No. I thought I think I used it. All the crafting stuff, no? What do we use for the... I remember all the transforms. There was a bunch of function which we're using. Come on. It was not in work manager. It was not here. I changed it. I'm pretty sure it was here. I'm pretty sure it was where we had all the combinations and combinations and transformations, where we were doing all of that stuff. Maybe we use double linked list, because there is also the double linked list, and I think now that no, but linked, there is nothing with linked inside of this. Did I change it at the end? I don't remember exactly, because I did it quite some time ago. But I'm surprised, because it should be inside this class. No, I remember where is it. It's in cache manager, because actually is where we load. Yeah. Is where we load cache manager. I think it's inside of this. I think it's inside of this. PS trade combinations. Yes. Did we go for only T array at the end? I was thinking. We use T maps. So I did not. At the end, I did not use the linked list. I used a T map of uint, and then I was having my thing here with array. You know, I mean, I can also use an array. It's no problem. To me, the only important point is that I need to be able to remove and add elements to a list. Now, if it's a linked list or if it's an array, I think it's not too much of a problem because I don't have to insert elements in the middle. I think I'm just removing an element and adding another element. So I think it should be fine. So maybe we can change this to. Let me just try to change it to a T array and see what happens. A T array of T pair, right? Yeah, a T array of T pair I think would be enough because I think with linked list we don't have some functions that I can easily use. So I think I'm making it more complex. You know, I'm making it more complex than what it should be. Let me just make it a T array. And so in this case will be is empty or num equal to 0, right? I think we can do this. Sorry, here also will be like this. Yes, and here will be. Okay, so here is basically if he didn't find, right? And here I think we can have add, just a normal add, and I add in the starting point. Okay, so I think now it's working a bit better. Why it doesn't like this? Directions. Is it remove or what is it? I think it should be remove, right? Remove at. Remove at, and then we have the index. Okay, remove at. So, okay. So I think that's good. So we are keeping the same algorithm, okay? So if the path does not exist, we can just return this one initialized to 0. I mean an empty array. So we basically return an empty array, and then we will check if there are no elements in it. Then we know that then we know that it's GG. Okay, so I think this part should be fine. Then it will have to be revisited, but I think this part should be fine. So now let's try to see this part. This part, proceed in the given direction to find our next point. So here we need to get a new point. We said that the point is a t-pair intent, right? I think a vector 2D would have been okay, but t-pair intent of this thing then is our point. So we need to get our starting point plus the current direction. Okay, so here we need to increase. So depending on the direction, we need to. So we start from this, right? We start from this, but then what do? We should switch, right? We should switch on current direction. We should switch on current direction, and how do I switch? I switch like this. And then I should, based on the different cases, so case again, puzzle game, direction up, right? So in this case, why is it indenting that? In this case, we basically need to make our point one less in the y, right? In the y-axis. So we can just say point of, how does it work? How can I get over t pair my what does it, no, it's key and value. Yeah, exactly. So I get my key. So I basically set my point, right, to a new pair. I think I can use a new pair, right? A new pair which has the current key, and then I take the current value -1, right? So I go one up. Can you do this? I don't know if you can do this. Doesn't like it. What the fuck? T-pair. Can I create a T-pair like this? T-pair int. Why it doesn't like me? Doesn't like me, huh? Error type. Why error type? This returns key, returns an int, and value returns an int as well. So why I don't like it? Wait a second. Why doesn't like? A bit confused. You like that? Why doesn't like this? Why doesn't like this? It's not a pointer, it's just a normal structure. And key is giving me an integer as a result. Integer, tuple, private, tuple storage, integer sequence. I don't know. It's a bit weird as a saying, but it should come out as an int. So, what is the problem? Do you understand? Can you help me, guys? If you understand what I'm doing, what is the problem here? Why it doesn't like to assign I have my point, okay, which is this starting point, which is a t pair of intent, and it doesn't seem he wants to extract the key and the value. Why? Third does not evaluate to a function taking 0. Okay. He has a parameter? No, key. I don't get it, guys. Ah, fuck me! It's not a function. Is okay. It's not a function. Is directly an attribute. I mean a value of that. So without okay, I was confused. Okay, so it's point dot key and point dot value. So it just extracted like this. They are two attributes. They are not functions. For some reason I was thinking they were functions. Okay, so we created this new point, right? Which is a t pair of key and value minus 1 because we are going up. Now we have to do the same for all the other cases. So in case we want to go down, it will be this, and this will be +1. And if you want to go right or left, and etc. Now the problem will be that exactly like if he's in the next line, so +1 you add it here and we remove +1, and the last case is that we go left, and so we have -1, and okay. So the problem is that we are moving in the cell. So going back to our picture, right? So we started in a certain location like this, and we are moving down or left, right? Down or right. So down or right. So we are testing all the possible positions, and it may be that, like in this case, I cannot go left because my puzzle is finished. So if my the board is finished there, I don't have another cell. So in that case, it's checking here. So point is out of bounds, or point is already visited. Return null. So yeah. So if the point is out of bounds, I need to say if my point is out of bounds. Okay, that's pretty simple. I should just say if point is out of bounds. So point is out of bounds. I need to check if my point dot key is greater than the maximum size of the puzzle, which at the moment I didn't yet define, but I need to have max size. Right, I need to have a max size of my puzzle, max puzzle size, or point dot value is greater than max puzzle size. Considering our puzzle is always a square, I mean it's always same length horizontally and vertically, I think we can just so if this is the case, we return null, or if, so again also here we need to put this, if the point is already visited. So if my how do I say if my point is already visited? Maybe I can return this, but I'm not fully sure that I'm doing the right thing here. I will think about it later, but I don't know if I can I can just return an empty array and say that, because then I will have to check it, I have to check that. Yeah, but we are checking it here, so I think it's fine. I think it's fine. So these max puzzle size, we need to define it, okay? So it is not defined today. I think we need to define it in our puzzle game somehow. So we will have an int which is max puzzle size, right? We will have to initialize it then, but for now it's okay. So if the point is already visited, if the point is already visited, so my structure is we had the mark visited, no? We created the mark visited, didn't we? We only did it this way? Okay. So we need the actual puzzle to be which is this one, right? So we need to generate, we need to we need our actual puzzle as an output, right? So we need this to be our puzzle grid. So this is our puzzle grid, okay? And so in this puzzle grid, which will be initialized, so when I initialize it, I will have to add a number of lines and a number of T-array cells. Yeah, that would be easy. Okay, so yeah, that's fine. So I will be able to initialize it, and then after I initialized it, right, so in my puzzle grid, so what we are saying here is it already visited, yes or no? So we need to check if in our puzzle grid, at a specific x, right, a specific x which corresponds to my key, right? If we get, why doesn't like it? Okay, but for now it's okay. If we get my cell, right? My cell is actually an array of no, wait. My puzzle grid is an array of puzzle columns, okay? And puzzle column is actually an array of int, exactly. So here my cell, I can get the point dot value, right? So I'm basically searching the right cell in my array, right? Now when I have that, if the point is already visited, so if this one is equal to 1. We have to create, you know, a kind of syntax, a kind of you know, yeah, syntax for our puzzle. So if is 0 means that has not been visited yet. If is 1 means that it has been visited already. So if it has been visited already, we don't want to continue in this direction. So it means that this direction is bad. And so I'm going to return an empty array. So we go up one level, and we go backward. We trace backward 1, and we continue in another direction, right? So that's the idea. So avoid touching crossing path so far. This I have no idea what it is. Let me think about it. So for each neighbor in 2, 3 rectangle forward, left, and right of the point. Okay. If neighbor is within bounds and already visited, if the neighbor is within bounds and already visited, then return null. Okay, so it's just checking that it's not selecting another. But didn't we do it here already? Ah, no. Here we checked if our self, you know, is already visited. So if we are okay, yeah, if this cell is fine. Now we're here. We are looking around us. In all, like if I'm here, I'm looking at all these other cells around me, right? I'm in this right in the middle. I'm looking at all the other cells around me to check if there is one that is valid, available, right? And is not already visited, right? So it's interesting that it goes in that direction. I mean, it's like trying to understand the forward. I don't know. I think it's because it. I think it's because it's simpler for him. I mean, you're not checking these 3 at the top, which anyway makes no sense. Yeah, so it's just ensuring that we are going in the right direction and we are checking. Okay, that makes sense to me. So for each neighbor in the 2, 3 rectangle forward, left, and right of points, if neighbor is between bounds and so this one is not very easy to do. I mean, how do we do a for each of all the ones that are around? I have no idea. I need to create a new point. I mean, the only way for me is to create a new t-pair which has those values, right? So I will have to create, is there a better way? I don't know. Like I take my point, I'm just thinking because I'm a bit confused, you know, when we enter here, if you already marked the square where we are, and it seems not. So we are marking here, and now the only thing I'm asking is why we are checking before marking if we have neighborhoods which are available. Why we are checking if we have neighbors available if in theory we could have finished the game already, you know. So let's imagine that I have a path of 3. I'm here, I'm doing 1, 2, and 3. So I'm entering this one, and my finishing line is 3. So why I'm doing this piece before the mark visited? I'm very surprised about that. So in theory I should mark it, because he's returning back. He's returning back in case for each neighbor in the 2 by 3 rectangle forward, left, and right of point, if neighbor is within bounds and already visited, return null. So if he cannot move in any other place, return null. But I think I don't think it's correct, because we didn't yet mark ourselves. If we don't mark ourselves here, this will never work. Right? Because we should check if the game is ended. Because here is where everything starts. So we are in this situation, right? So we enter this one, and we are here. So we are in the first. Yeah, I don't know if the first one is automatically marked. That's probably why. Yeah, the first one is automatically marked. I mean, it's automatically part of the game, right? Yeah. That's why. So okay, so let's assume that the first one is automatically marked. Now, it's choosing a direction to go, and it chooses, for example, to go to the right. Okay, it's choosing to go to the right. So I enter this function, is saying right, is adding 1 to this key. My point becomes this one to the right. Okay. And at this point is checking if this point to the right is valid or is out of bounds. In this case, it's valid. If the point is already visited, is not visited, so it's good. And then this is what is strange to me. It's not marking it. I mean, this one is good then. I mean, if why it needs to go into this thing and starting to check the rectangle without marking this as visit? I think this is wrong, boys. I don't know. I don't want to change the algorithm, but to me it is completely wrong. I don't get it. To me, this part should be after we mark ourselves as visited, you know? Because we found out that we are not out of bounds and we are in the right position. So we should mark it. So we should make it blue. Now, so when we make it blue, we should check if we reached the final length. So if the remaining length is 0 or not. And this remaining length, I don't know if he has any, but anyway, the remaining length should be remaining length minus 1, right? But if the remaining length is 0, then we say good. Our pad is working. Our pad is working, and so we can bubble up. Yeah, we can go back once and say that we have a new path point. So in theory, I should return. So in our case, will be to add this point to our array, right? So this will be to add to our array. Yeah, I don't know why I don't have it as a variable. I think I need to have my path, which is this one, right? As I think I need to have my path as path. So generate. Let's call it generated path, right? Which is an array of t-pair. Yeah, exactly. So this one I should have it as a variable. Now, what I want to do here is to add to my generated path. I want to add my point, right? Perfect. And then I want to. I don't know whether is this return. Is it? I mean the return. No, yes, it's good, but. And then I return from this function. And then I return from this function. So I bubble up and and this will return to the previous cycle. Okay, it's fine. Then after so in case it's not the end, so in case the remaining length is not the final one, so I don't have only a path of 2 but a path of, I don't know, 5 or 6 or 7, then I want to look at all the neighborhood, right, around me, and in particular I want to look at 1 and 2, right, because I can move from here, I can only move here and here, right. So exactly, so this is what it's saying. So for each neighbor in 2 to 3 rectangle forward, left and right of point. So yes, I don't exactly understand why it's saying in the direction. Because I don't want to go backward. Yeah, I don't want to go. I don't want to go backward, which is the one that I'm coming from. Okay. Yeah. So here I'm entering with direction right, so I know I'm going to the right, and so I think I need another major. I need another big switch here, because I need to. Based on the direction I'm going. Based on the direction I'm going, I need to check. But do I do it randomly or do I do it? Yeah, it should be random again. Huh? Because here is searching. Here is searching the next one. So it should be as random as this one that we did at the beginning. You know what? I think I will check also the backward. I don't give a shit. I will check also the backward. Because it's easier for me in the algorithm than checking also the backward and just seeing that it's already visited. Because anyway, it's already visited. So we will get it as already visited. So I can create, so I can create again the same directions 1, 2, 3, 4. I can randomize. Do I need to go through all of that? Yeah, I need to 4 on these 4 directions. I need to 4 on these 4 directions, and I need to randomize 1. I need to get my direction. I need to remove it because I used it, and then I need to do what? And then I need to do what? I need to check if it's a possible path. So I need to check if this neighbor is within bounds and already visited. So let me remove that. So I need to check. I need to check if I'm within bounds. You know what? I have a feeling that this thing is duplicated. Let me just check the original one for a second because I'm getting confused. So when he goes here, I'm entering with a direction, okay? So proceed in the given direction to find our next point. Okay. So point, start point, current direction. So this one, I think I did it, right? I did it in my here at the beginning. Proceed in a given direction to find our next point. Okay. And this become point. Okay. And this I did. Then it's checking if he's out of bounds or already visited, and he returns null and he goes back. Okay. Then it's checking if this is what I don't understand. Why? So here is proceeding in the direction, you know, which for me means that I'm moving from one cell to the other and I'm assigning it to the point. Then why the hell is doing this again? Why is checking all the neighborhood of that one if, yeah, without marking that as visited? Exactly. So this is the problem I was discussing before, right? So he has to mark if this one is good, is not out of bound, is not already visited, is good. So we should mark it. And did someone answer to this one? Because I think it's kind of broken. But I mark it as visited. Then then after marking it visited and checking the endpoint, it does this part. So it's looking all around. Now I'm debating that this part is exactly the same as this one. So I don't know why it's doing it twice. Unless I'm not understanding it, but for each neighbor in 2x3 rectangle forward, left and right of point, if neighbor is within bounds and already visited, return null. So here basically, if there is at least one neighbor that is visited, it returns null. I mean, it goes back. Why? If there is at least one that is visited, at least one, so the other ones will go through, right? Is this for each including everything here or not? No, it seems that it's just checking if there is one so it's like we are here. So let's assume that we go down. And no, wait, let's do it differently. Let's assume that I go down and then I return up. Okay, so I'm here, I'm trying to go up, and so I did this. So what that part of the algorithm is doing is checking all around him in the direction. So it means that it's checking this one, and this one, right? In the direction around him in the 2x3. It's checking if one of this is already visited, and in our case it is, because the one on the left, this one is already visited, and if it's already visited, it basically bails out. I don't understand why. I mean, it should not bails out, it should use this one or this one. I think the algorithm is written wrong. I think this thing is written wrong. It's not possible. Is this thing I completely don't understand. Okay, so it's not what I want to do. What I want to do is this part. So for each of the direction in a random order. So let's say that this one we don't do. So we don't do this. Why we should? Okay, so that thing we don't do. The algorithm was saying that we should have done this, right? But I don't get it. So we don't do it. We just don't do it. So now the other thing that we should do, which I think is correct, is this one. So for each direction, blah blah blah, right? For each direction, blah blah blah, search for a feasible solution for a small subproblem. So let me copy this. Let me copy this. Let me remove this a second, otherwise I'm getting confused. So here what we are doing is we're doing this for each turn direction, forward, left, and right, current direction in random order. Okay, so we have our direction. We extract one in random order, and then we need to do this. We need to search for a feasible solution to a small subproblem. Okay, so basically it's going to extend again. It's going recursive, right? So it's going recursive. So is taking this direction, which is the current direction, and is passing it here. Yes, let's call it turn direction. I think it's better. Turn direction. Okay, turn direction, because I think we had a current direction already coming in. Yes, exactly. So that's why different variables. So we pass this. We pass our start point, but careful though, because our start point now should become our point. Absolutely. No? Why this is not point? Why is still start point? I'm confused. No, it should be point. It should be point, because we need to move. I'm not fully sure, but we need to start from the new point and go down. Yes, absolutely. So this one should be point, not start point. We should use the remaining length minus 1. Yes, this is good. By the way, remaining length, I think we never declared it. Why is not complaining about it? No idea. So remaining length is the length that we are. Wait. I know why. Because we are passing the length to our. We are passing the length here. It is one. Okay, good. So we are passing this. So our remaining length minus 1. Yes. So it's minus 1, and we want to return something like that. I'm still not sure I have to do this, but I'm a bit confused about that. So I go down once. And I try to go in that direction. Okay, perfect. Now, if the path is null, I think we said if the path num is equal to 0. If the path num is equal to 0, then we just continue. We try another direction, right? And if everything is going okay, so that point is a good one. If that point is a good one, extend that path to include this point. If it's a good one, I'm adding this point to the path. Oh my god, but it's not working because this way will be backwards. Okay, we will have to see, but my feeling is that we are getting the path backward from the end to the top, to the beginning, from the end to the beginning, right? Because here we are in the recursion and we are at the end of the function, and when we find one which is good, we add it to the path to my path, and we go back. Yes, we go back, and means that we will be coming back in the previous cycle here, right? And we will check if it's good or not, and we will add it to the path and go back, add it back. So yeah, so we will base, so the way it does it is that it's finding a path. Let's assume there is this, and then when the recursion finishes, is going backwards and adding it to the array. So actually our array will be done like this, from the end to the beginning. But I think it's okay. I mean, we don't need to. I mean, it's not a big issue to me. I mean, it's fine. We will just have to navigate it the opposite way, but it's okay. It's okay. So he's adding this to the point, and then he's returning path. The only thing I really don't know is why we need to return the path where we are not just returning a boolean and checking the boolean. I'm so surprised about that. Because let me think about it. So we are entering the first extend path with this block. Then we are cycling on a direction randomly, and we enter another extend block with this. Then we do the same again, and we go here. Then we do the same again, and we go here. Then we do the same. For example, we want to go down here, but it's not possible. It's not possible. Did I mark it as visited? No. Did I add it to my array? No. So I will just go back and try another direction. We go back and try another direction. Yeah, so why I need to return to the previous recursive, let's say n-1 function, the full path. I can just return a boolean and check if it's a good path or not. And anyway, I added the point here. If it's not good, I'm not gonna add it. Right? I think this return path is a stupid idea. I think we can just return a boolean. Okay, so then if nothing works, okay, if none of the directions are good, because I didn't find a point, so I need to go back that's why probably we need it. That's probably why we need it, because I need to go back and I will remove this path. I will remove this because it's saying, okay, I cannot go anymore in this direction, right? And so I need to undo it and try the other direction, right? So to undo it, I will mark it as false. Okay, it's good. I'm marking this point as false, and I'm returning that this path is not good. So in our convention for now, when we said that, we said that we return an empty array. So we return an empty array, right? Okay. I think we are not too far. I think we are not too far from what we wanted to do. But you know what? I think I really want to make this. Yeah, we are missing market visit. So market visit. So market visit. Market visit should take a point and a boolean. Yes, and it should mark in our puzzle. Yes, it should mark in our puzzle, which is our puzzle grid, right? It should take our puzzle grid. Our puzzle grid is an array, so it should take cell.key, and from this cell.key, it should extract cell, and of this cell, it should take cell.value, and this one. This one, it should assign it. So if mark, it should assign it to 1, else it should assign it to 0. Right? So this is our marking, our mark visited. So it's working on the puzzle grid. Okay. Succeeded, boys! Holy shit! At least we compiled it. Okay, so now we will have to test it, which is a bit annoying, but I need to go dinner because it's 9 p.m. I have some. It's 9 p.m. I'd like to have dinner. But just to recap what we did, okay? So that everyone knows what we did and we can continue then from there. So we have done the following things. We have decided, we have reviewed the type of mini games we want to have, okay? And in particular, we decided the categorization of the mini games and which kind of mini games we want. Then we decided to focus on the armor one, which is one of the most complex that we decided to have, because you need to follow a path with a ball and or with a marker. You need to follow this path and such. So you need to generate a kind of a puzzle, okay? And the puzzle we are going to generate is something like, there will be a grid, and in this grid there is a path you need to follow, like this one, right? And so we want to generate an algorithm, to create an algorithm that is creating this path, right? And so what we decided, we decided that we have 4 different sides of puzzle. So the 1, the 4, the 9, and the 16, which I think is a good decision, by the way. I think I like that. We decided we have the starting position always in the same place, right, for all the puzzles. And we decided to try to use an algorithm to generate this path. Now, we found the algorithm on the internet. It seems a bit broken to me, but I think I will learn through my mistakes. Maybe it's correct and I didn't understand it. We created a util class, a utility class, which allows us then to call this function from the blueprints, so from the Unreal Engine blueprints. And we created a function that is called generate puzzle grid, which returns a T array of puzzle column. Which returns a T array of puzzle column, perfect, which is basically is our puzzle. Okay, so it's something like this, where we will have 1, 0. I mean, we will only have the ones actually, but 1, 1, 1, 1, 1, 1, and 1, and this will be describing the path that we need to follow. Then the next step will be to put the different shapes, and so the number will be corresponding to the shape, but we will do that later. So so this generate puzzle grid needs to call this function actually, right, which is returning. We need to call this function with the puzzle side. Well, you need to initialize the puzzle first, so you need to initialize the puzzle with the right sides, and then with all 0, and then it needs to search a path, okay, and this search a path is this one, and it will take simply the path length and then the starting point. Well, actually the starting point for us is very easy, because the starting point for me will be always 0, 0, right? So it would be a T pair of 0, 0. That's it. And then what? I think I need to initialize the puzzle game. Yeah, maybe we'll have a constructor or something. Okay, so we will have a constructor with with the number of with the sides, which will initialize the array. Yeah, we will need to have that. We will do it, and then we created this. Now we have to test this to see if it works, but I think it directionally is okay. So this thing will return then the path, which is this path that we can use to do our next step, which is to select the different cells. And so what I'm expecting is that after we have our 1, 1, 1, 1, 1, like I said, right, we will do another pass of this, right, another pass of this, which will be to take this to take this and put inside of it the right symbols, which are the one that you see on the top left. I think these are all the symbols we want. And so you will see a path like this, a path like this. Okay, this is already a mistake because we said that we want to go down. So it will be something like that. This will be like this. This maybe will be like this. This will be like this. This will be this. And this will be this. Okay? And so we will have generated the path and use the tiles, which are this one at the top. By the way, I have to save this. If I'm not saving this, let me save it as a real mission minigame armor. Actually, we can do this better, right? We can do this better. In theory, yes, because we have, you know, the symbol. We can put them all horizontal or vertical. So it's wait a second. Wow, why so big? Okay. We can put all the symbols in one line. So the symbols are this one, this one, this one, then this one. But before this one, we need this, just in a logical sequence, you know. Just in a logical sequence, we need this one after, way after. I don't know when, but we'll see. Then we need this one, which also will be able to be rotated. So it's basically a two sides. It's not big enough. Fuck it. I'm gonna do it. I'm gonna redo it. So this one. Okay. Then logically we have this one and this one, and then those two, right? Yes. So we have this one and this one, and then we have. Well, actually, there can also be another one, but I think for now we are enough symbols. And then there is this one. And then there is this one. Okay. So I think that these are all the symbols that we need. So I can delete all the rest actually. Right. So it's basically, and everyone can be rotated 3 times. Right? Everyone can be rotated 3 times to give all the possibilities. So going through vertical, horizontal, corner 4 positions, this one 4 positions, this one 4 positions, this one also 4 positions, this one just with a square instead of the. Now there could be another one, right, that I'm thinking, but I don't know if I want it, which is basically this. I mean, we go to the center, we go to the left, and then we go back. But I don't know if we have enough space here. Well, like we have it here, I think we have it here as well. But yeah, maybe we have enough. But I don't know, we can start with these symbols. And this will be completely randomized. So the next randomization we need to do is that we need to know where we enter and when we exit for each of the cells, and then to decide the symbol to use, which in certain cases will be possible to use corner, like this one is corner, this is corner, this is corner. So we will decide it based on the complexity. Maybe we will assign a complexity level. We will assign a complexity level. Yeah, that's a good idea. We will assign a complexity level. Like this one will be complexity 1. There is complexity 2. There is complexity 3 or 2.5. There is complexity 3. There is complexity 3. There is maybe it is also complexity 3. And there is complexity 4, and there is complexity 4. Right? Or we can say that here I have to do 1, 2, 3 turns. So I enter in the grid, and then I have to go up, right, bottom, right. So I have to do like 3 turns. Here I have to do 4 turns, so these are more complex for this, but this one, I don't know. I'm unsure about this one in the middle, if it's really complexity 3 or should be complexity 2. I mean, if I have another one complexity 2 like this one, here we are changing the direction only once, so here we are changing the direction multiple times, here we are changing the direction only once, and here we are changing the direction 3 times. So yeah, I think actually this one and this one can be complexity 2. Right? Yeah, so we will decide based on the complexity how many we want to use. So we will need to scale it up. So it will be like multiplication, right? So we decide the top complexity of the puzzle, and then we say, okay, if it's 100, you will use the longest path, and well, the longest path. We made a mistake. We made a mistake. The mistake is that the current algorithm is finding one path. No. It's testing all the possibilities. It's testing all the possibilities. If it doesn't arrive to the number, so to the length, it goes backward and it tries again all the possibilities. Yeah. It tries again all the possibilities. So it's So it should be fine. Should be fine. I don't know. We need to test it, but I think it would be fine. Okay, I want to test it, but I cannot do it now. I will do it later. But the point is that to test it, what we will do, we'll just add a printout every of the final array, and then we will see how it comes out. Okay. Because we should. So what I'm expecting is to get our final puzzle game, right? So there's this one, this T array. So I think our game at the end. I'm still a bit confused, but I think it's the generated path. Yeah, exactly. So the solution. I mean, our generated path is the one that we want to print out. So print out generated path. So we will print out this thing. I don't know how to do it because what is it? Is an array. Well, it's very simple. We just print out. We just we just echo, we will just ulog, whatever, right? All the give me a ulog. I know you want to see it. I know I want to see it, but at the same time I need to go. But I would like to finish this. So yeah, a ulog like this, okay? So a simple ulog where we will go through. So we'll do a for int whatever equal to 0, usual shit, less than the max size, max puzzle size, max puzzle something, max puzzle size, and then we will print out, right? We will print out, come on, we will print out the full array, right? We will print out the we will print out 2 columns, and here will be just generated path, what is this thing, is I think we can just print the T pair. I don't know if it will work, if a T pair can be printed, but I don't know. Dot, probably not. So this will return, why is it not working? No. Wait a second. I think it's just this. Right? So we print out the key and the value. Right? We print out the key and the value, and that's it. Generated path is unknown. Yeah, because it should be the one inside my game. Something like that. Something like that will print out the whatever it generated. So the result on screen will be, for example, in this case, it will be 0001, right? 11, 12, 13, 33, 43, something like that. I don't know. Okay, so this will be the result of the cells that we are selecting, and if that is working, that would already be a pretty big step forward in doing this. Okay, boys, I'm going. Thanks for watching. I know it was a bit of a weird session. I will rename the stream in mini game algorithms or something like that, because we didn't see a lot of visual stuff yet, but I'm telling you that after this we can go for the visual part. Okay, so we can go back to our Blender and create all the path, and understand how to lay it out in 3D. See you, boys. Thanks for watching.